Lesson 5-6, Solving Systems Using Matrices. Big idea. A system of linear equations in standard form can be written as a matrix equation that can often be solved by multiplying both sides of the equation by the inverse of the coefficient matrix. So that's important. You're going to multiply both sides of the equation by the inverse of the coefficient matrix. Okay? So, moving along. It says the matrix equation 3, -1, 2, 4 times the matrix xy equals 14, 0 is called matrix form of the system. Okay? This system is the matrix form for this system of equations. Notice where they get the 3, the -1, the 2, the 4 at. This is important. You're going to have to do this on your quiz. So all these are coefficients. So that's why we call this the coefficient matrix. This is the variable matrix because it has our variables x, y. And this is our solution matrix because that's what it's set up equal to. Okay? It says the matrix right here is called the coefficient matrix, as I just stated, because it contains all the coefficients of the variables in the system. The matrix 14, 0 is called the constant matrix because it contains the constants on the right side of the equations in the system. So if you look at Quiz Yourself 1, it says expand. Okay? What they want us to do is to verify that this represents this. Okay? Well, all you do is take row 1 times column 1. Okay? So 3 times x is 3x. -1 times y is a -1y. Equals my top number, which is 14. Okay? Now, on the bottom, 2 times x is 2x. And 4 times y is 4y. And that all equals 0. So we just undid this to verify that that does show its same meaning. Okay? Now, where does solving these matrices come into play? It says, how do you solve a system in matrix form? Think how you solve the equation 3x equals 6. Well, in 3x equals 6, we got to get x by itself. So we have to divide by 3. All right. So when I divide by 3, I get 1 times x equals 2. Well, in matrix math, okay, we have some matrix A times the variable matrix. I'm just going to call that x. And that equals B. Okay? This is the solution matrix. Coordinate matrix, variable matrix, solution matrix. And what we want to do is get our variables by itself. Well, in matrix math, you can't divide by some matrix. So what we have to do to get 1 in matrix math is multiply by the inverse of the coefficient matrix. Whatever you do to one side, you have to do to the other. Okay? So, when doing this, the inverse matrix times the coefficient matrix is going to give you the identity matrix. So it's the identity matrix times x equals, and you always have to write this way, the coefficient inverse matrix times the solution matrix, because a 2 by 2 times a 2 by 1 works. A 2 by 1 times a 2 by 2 will not work. Okay? So you always have to do your coefficient matrix first, the inverse of the coefficient matrix first, and the solution matrix second. Well, the identity matrix times any matrix is just that matrix. So to find a solution to every one of those problems, as we have seen, is all you have to do is take the inverse matrix of the coefficient matrix times the solution matrix. So let's dabble in and show you what I'm talking about. We will need our calculators for this. Example 1 says, solve the system 3, -1, 2, 4 times the matrix xy equals 14 over 0. So the first thing we want to do is obviously let my calculator come up. But what we want to do is type this coefficient matrix, into our matrix. So if I hit second function matrix and I want to put it in A, so I got to edit it. Need to write these steps down if you don't know it. It's a 2 by 2, so I just hit enter, enter. And I want to put in 3, -1, 2, and 4. Okay, now I'm going to hit second function quit to get out of there. And now I want the inverse of that, as you can see right down here. So I hit second function matrix. I labeled it in A, so it's number 1. And I want the inverse of that, so I just press this little button with the -1 symbol. And it's going to tell me they are decimals. Well, if I don't want to write all those decimals, what do? Well, I hit math, and I hit fract. And it's going to change my answer to fraction. So 2/7, my inverse matrix is going to be 2/7, 1/14, 3/14, and a -1/7, I believe. Let's go take a look. Yes. Okay. So that's my inverse matrix. So on the next step, after you find your inverse matrix, you have to multiply that on both sides. So 2/7, 1/14, a -1/7, and 3/14. Okay. Same over here. Sorry, messed that up. -1/7, 3/14. So my solution, this becomes the identity matrix, as I said before. The inverse times the coefficient matrix is going to give you the identity matrix. So my answer is going to be, all I have to do is take this times that, and that is a 2 by 1, so I'm going to go to my calculator, type in that equation. So I hit second function matrix. I'm going to put that in B, so I'm going to edit B. And that's a 2 by 1. Enter, enter. 14, 0. Second quit. So what I want to do is take this matrix and multiply it to my solution matrix, which is B. And I get my answer 4, -2. So that 4, -2, x is 4, y is a -2, is where that system of equations intersects at. 4, -2. A lot easier. Let's look at example 2. It says use these matrices to solve. Okay, so what I need to do is make a coefficient matrix, and this one's going to be a little bit bigger, times my solution my variable matrix equals my solution matrix. So my solution is 2, 28, and a negative 16. This is x, y, z. And now for my coefficient matrix, and I want you to pay attention to this. You want your x's to go all down this way, your y's to go down the middle, your z's to go down your right-hand side. So you have x's, you have y's, you have z's. So on my x, on my top one is a 4. On my y is a 2. On my z is a negative 2. For my second row, what's on my x? Well, on my x is a 2. Don't put this with the y's, it's with the x's. And then I have a 4 on the z. So you're asking, what should you put under your y? Well, there are no y's, so you need to put the number 0. Same thing down below here. There are no x's. So there's a 0 on the x, a 3 on the y, and a negative 2 on the z. So as I said before, to find our answer, all we have to do is take the inverse matrix times my solution matrix. So I'm going to put this into my calculator. Second matrix. As you can see now, this is a 3 by 3, so I got to edit that. 3 by 3. And I put that in C, so you got to pay attention where I put that in at. I put it in C, okay? So it's 4, 2, negative 2, and it's 2, 0, 4, 0, 3, negative 2. Okay, so now I go second matrix. Okay, I need to put in D, I'm going to put my solution matrix, which is a 3 by 1. Okay, so 3 by 1, so it goes 2, 28, negative 16. So the process is going to be, for this one, since I put it in C and D, I got to take the inverse of C, so second function matrix, C inverse, times D. And that's going to give me my solution, which is that right there, 4, negative 2, 5. So that's going to be 4 x, y, z, 4, negative 2, 5. And you see how these line up? X equals 4, y equals a negative 2, and z equals 5. Now, what if you wanted to know what the inverse was? Well, then I just need to put up here the inverse of C. Okay, so if I go second function matrix, if I say C, and then I just want the inverse, I could easily write my, change it to fractions. I can easily write my matrix right here, down in here. Okay, I'm not going to waste your time with that, just as long as you know where you can get that. Okay, moving on, it says the system determinant theorem. It says an n by n system of linear equations has exactly one solution if and only if the determinant of the coefficient matrix is not 0. Okay? So, if it has a determinant, you know you have one solution. If it doesn't have a determinant, you know you have no solutions. It says in the previous lesson, you calculated that the determinant of a 2 by 2 matrix. While the calculation of a determinant of a larger square matrix is tedious by hand, a calculator can find the determinant automatically, which also helps. We found out how to use the determinant on our calculator in the previous lesson. When the determinant of the coefficient matrix is 0, to determine whether there are no solutions or infinitely many solutions, find a solution to one of the equations and test it in the other equations. If it satisfies all other equations, there are infinitely many solutions to the system. If the solution does not satisfy all other equations, there are no solutions to the system. Okay? So, let's check this out. Example 3 says, consider the system. Okay? A says, show that the system does not have exactly one solution. So what they want us to do is check out the determinant of the coefficient matrix. Okay? And if you remember, my coefficient matrix is 3, 2, 6, 4. And to find the determinant of this, all you have to do is take 3 times 4 and subtract 6 times 2. And as you can see, we get out 0. So then we have to figure out, is it going to be infinite solutions, or is it no solutions? That's our decision right now. Infinite or not infinite? Well, infinite solutions or no solutions? Well, let me let you in on a little secret. If it's infinite solutions, these equations are going to have a multiple to each of them. So some number times this top equation is going to give you this one down here. So if you look at it, we can tell 3 times 2 gives me 6. Okay? 2 times 2 gives me 4. Does 14 times 2 equal 10? No. 14 times 2 is 28. So since 14 times 2 did not give me 10, this is a no solution problem. Now, if it worked for all those, 3 times 2 is 6, 2 times 2 gives you 4, 14 times 2 gives you 28, this was 28 here, then it would be an infinite number of solutions because those two lines are exactly the same. That's all I have for you today. Please enjoy. We'll see you tomorrow.